Hi everyone, today we will talk about integration of e-payments in software projects and their usage. This presentation has been prepared by Prokopenia Polina, a student of computer science major in informatics faculty in UKMA. Let's start with what are e-payments. Electronic payments refer to the digital transfer of money from one entity to another using electronic systems instead of traditional cash or paper-based methods. Key characteristics include no need for physical cash, instant character of payments, enables cross-border payments, also uses encryption, tokenization, and authentication methods to protect transactions, and it's often integrated into software systems like online shopping or SaaS platform. Now, let's break down the key components of e-payment system and how they function together. It all begins when a customer initiates a transaction. They choose a payment method such as a credit card, digital wallet, and enter the payment details. First, we have the payment gateway. Think of it as a bridge between a website or app and the financial network that process transactions. When a customer makes a payment, the gateway encrypts the payment details and sends them to the next stage, the payment processor. Well-known gateways include Stripe, which is widely used for API-based integration, PayPal, which allows both business and peer-to-peer payments, and Adyen is a favorite among large corporations like eBay and Uber. Now, once the data reaches the payment processor, the real work begins. The processor acts as a financial middleman, handling transactions between the customer, the merchant, and the bank. First, it forwards the payment request to the appropriate card network, Visa or Mastercard. Then it contacts the issuing bank, that's the bank where the customer holds their account, to verify if they have enough funds, if the transaction is legitimate, etc. If the bank declines the payment, for instance, due to insufficient funds, the transaction fails at this step. If everything checks out, the bank approves the payment and the processor releases confirmation back to the merchant. At this point, the merchant receives a payment confirmation and the customer sees a payment successful message on the screen. However, the funds don't always arrive instantly. Depending on the payment provider, it can take anywhere from a few hours to several weeks for the money to be fully settled. This leads us to the merchant account. Unlike a standard business bank account, a merchant account is specifically designed to hold funds from processed transactions before they are transferred to the business's main account. This temporary holding period allows for fraud checks and dispute resolution in case of charge. There are several e-payment providers that you can choose from, and there are several factors that you need to consider. One of the first things to look at is, of course, APIs and SDKs, and most of the most popular providers provide quite good APIs that are easy to integrate. For global businesses, for example, Adyen offers multi-platform support and it's used by companies like Uber and Spotify. And for small businesses, Square provides a simple all-in-one solution. Beyond functionalities, you also need to consider security and compliance, and there is also a question of transaction fees and overall costs. Every payment provider charges fees for processing transaction, but the pricing structures vary. Some charge a flat percentage per transactions, while others include monthly subscription fees for additional services. There are also chargeback fees that are applied when a customer disputes a payment, and cross-border fees that can significantly increase costs for international transactions. Okay, now we're going to a brief example of how you may integrate Stripe in your app, specifically web app in this case. The first step is setting up a Stripe account. To do this, you just need to sign up on the Stripe dashboard and obtain two API keys, the publishable key, which is used on the front end, and the secret key, which is used on the back end. During development, test mode should be enabled to avoid processing real payments. Next, we move to installing Stripe's SDK. If we're working with Node.js backend, we can install the Stripe package using npm command. And for applications built with Python frameworks, we use pip install. We need to collect payment details on the front end. For this, we use Stripe elements. A simple form might look like this. This creates a card input field where users enter their payment details. Instead of directly handling sensitive data, Stripe always encrypts it before sending it back to the backend, so we do not need to worry about security here. To make this work, we also include the Stripe.js script in our HTML. Moving to the backend, in Node.js Express backend, the first step is to install the necessary dependencies and initialize Stripe using the secret key. The server listens for payment requests from the front end and creates a payment intent. It's a special Stripe object. When a user submits payment on the front end, the card details are sent to the server. The backend creates a payment intent that includes details like amount, currency, payment method type. Stripe then responds with a client secret, which the frontend then uses to finalize and complete the payment. And instead of storing or transmitting raw credit card numbers, Stripe uses tokenization to replace them with a unique secure token so that merchant server never directly handles or stores credit card information. And now that the payment details have been tokenized and securely transmitted to the backend, the last step is to charge the customer, again using Stripe's API. In Node.js, this is handled by the charge endpoint. The backend receives a token from the front end and uses it to create a charge request. If successful, Stripe processes the payment, deducts the amount from the customer's account, and transfers it to the merchant. The backend responds with a confirmation message, letting the frontend know that the payment was successful. And here I store a bunch of videos that you can watch if you want to go deeper into the topic, or you also want to know how to integrate PayPal, for example. And throughout this presentation, security was pointed out several times. And when handling online payment, security is a top priority. To maintain security standards, major credit card networks like Visa, Mastercard, American Express have established the Payment Card Industry Data Security Standard, PCI DSS. This global security framework is mandatory for any business that processes credit or debit card transactions, and failing to comply can result in fines of up to $500,000 per incident and the potential loss of card processing privileges. So you should also keep that in mind while developing your apps. And going to the history, looking back, in the early 1990s, online transactions were still in experiment. But with the rise of the internet, the idea of making purchases from a computer became a reality, and the first ever online transaction happened in 1994 when a customer used a credit card to buy a Sting CD for $12.50 on net market. Around the same time, Stratford Federal Credit Union became the first bank to offer online banking. By the late 90s, Amazon and eBay launched revolutionized e-commerce. However, online transactions needed to be secure, which is why SSL encryption was introduced. As e-commerce took off, there was a growing need for a secure and easy way to send money online, and in 1998, PayPal emerged as a game changer, allowing users to send payments electronically without sharing their bank details. Today, PayPal's influence is seen in modern wallets like Google Pay and Apple Pay, and today digital payments becoming even more smarter. One of the most significant developments is the rise of blockchain-based payments. But with online transactions increasing, so does the risk of fraud, and major payment providers like Stripe, Radar, and PayPal Fraud Protection use AI to scan transactions for signs of fraud, whether it's unusual spending behavior, location mismatches, or bot activities. And as fraudsters develop more sophisticated tactics, AI will continue to evolve. And while cryptocurrencies are gaining traction, governments around the world are also working on their own state backed digital currencies. known as central bank digital currencies. Several countries are already ahead in CBDC development, for example, China, where digital yuan is already in use. And many experts predict that more countries will introduce digital currencies in the coming years. There is also such a thing as super apps. In China, for example, WeChat Pay and Alipay allow users to send money, shop, book flights, and even apply for loans all within the same app. In Southeast Asia, there is GrabPay that integrates payments with ride hailing and food delivery services. And looking ahead, tech giants in Europe and the US are also moving forward super app models. For example, companies like Meta, Amazon, and Google Pay are already integrating banking and payment services into their platforms. So, moving to conclusion, over 80% of global transactions are now processed digitally, with mobile payments growing at an annual rate of 15%. It shows how consumers prefer to pay nowadays, and while digital payments offer convenience, they also introduce security risks. Failing to meet security standards can have severe consequences, and I here grabbed some links of real world examples of recent scandals in South Korea. The world of digital payments doesn't stand still, and for developers, keeping up with emerging payment trends, APIs, SDKs, and security measures is critical. As technology advances, digital payments will become even more integrated into our daily lives. Understanding their implementation is crucial for developers and businesses alike. Thank you for your attention.